Okay, find the total length of 12 pieces of wire, each 9 3/16 inches long. So, if we want to find the total length, typically we hear the word total, we think add, right? But in this case, we have 12 pieces, every one is 9 3/16. So, the word each quite often is going to lead to a multiplication scenario. I got 12 pieces of wire, 9 3/16 inches per piece of wire. So I could do 9 3/16 plus 9 3/16 and do that 12 times. But it's quicker to just do 9 3/16 inches, the length of one piece of wire, times 12 pieces, the number of pieces we have. Now the thing to be cautious of here is when you're multiplying mixed numbers, there's a requirement of the distributive property. What I'm saying is if I want to multiply this as it's written, I would have to multiply 12 times 9 and 12 times 3/16. I have to multiply both the fraction and the whole number times 12 to do it. The other option is to make the 9 3/16 into a mixed number and multiply it that way. They're both right. There's like not going to be a way that that's not the right way to do it. But I would typically, if it were me, I'd probably make it into an improper fraction. So if I do 9 times 16 is 144, plus 3 makes 147. This improper fraction is equivalent to 9 3/16 inches. We're multiplying that times 12 over 1. I would reduce before I multiply. Anytime you're multiplying fractions, always look for a reduction possibility. And all we're looking for to reduce is we verify that there's a number on top of the product and a number on the bottom of the product. It doesn't matter if they're the same fraction or different fractions, but there's a number on top and a number on the bottom that have a common factor. They both divide by the same number. And what you can see here is that 12 and 16 both divide by 4. 12 divided by 4 is 3, 16 divided by 4 is 4. Anytime you reduce, you're making numbers smaller. Anytime you make numbers smaller, you're making the problem easier. So it's worth doing, right? And then I just got 147 times 3 on top. Yes, Ashton?
How'd you get 147?
I did 9 times 16 and then added 3. So you take the whole number times the denominator.
Then what if it's there was 1 and 2?
That's another way of doing it.
You can do 12 times
You can do 12 times 9 and 12 times 3/16. I'm going to do it that way in a minute. But the typical way, if I'm dealing with mixed number multiplication, I change the mixed number to improper fraction. So, on top I got 147 times 3, that's 21, carry the 2. 12 plus 2 is 14, carry the 1. 3 plus 1 is, 3 times 1 is 3 plus 1 is 4. So we get 441 over 4. Then I just have to divide to get back to a mixed number look, right? So 4 goes into 4 once, 4 goes into 4 once, 4 goes into 1 0 times remainder 1. So 110 and 1/4. When there's no carrying or borrowing, you can pretty much just look at it and do it. If that doesn't work for you, that quick division, then it just looks like this. If I go to the whole long division technique, 1 times 4 is 4, subtract 0, bring the 4 down. 1 times 4 is 4, subtract 0, bring the 1 down. 0, and that's remainder 1, which means 1/4. If I went with the other possibility, I'm multiplying a whole number times a mixed number. This is the only time I'd ever do it this way. If I got mixed number times mixed number, always go to improper fractions, always. But in the specific case where it's a whole number times a mixed number, whole number times whole number, 12 times 9 is 108. That's this product here. And then 12 times 3/16. That's 12 and that's 16 reduced to a 3 and a 4. That makes 9/4. 108 and 9/4. And then of course 9/4 being an improper fraction in a mixed number is bad policy. So 4 goes into 9 2 times, remainder 1, so 2 and 1/4. So 108 and 2 and 1/4 makes 110 and 1/4.
That looks a little like easier actually.
And again, again, it only works if it's times a whole number. If it's times another mixed number, then you gotta do whole number times both, fraction times both, and it just gets to be really messy. So the improper fraction technique's more common in this scenario.